Hello everyone, this is Team Quantum Leap and I'm the team leader, Chan. So previously we've talked about how we come up with our ideas and how we initialized as the very first step. But now in this particular presentation, we would like to present our final product for this topic that we've developed from our initial ideas and turned it into a realistic solution. But before we dive right into it, let's take a look at our design thinking concept and data from the survey we conducted that we mentioned in the previous one again.
Hello again. So today we are going to discuss how we can enhance support for international students. When the new international students come to a new culture and environment, it's already a challenge for them. And also, when the language barrier is also added, it becomes makes the full participation really difficult. So, as a solution, we started from ourselves as being international students in South Korea. So actually, we made some polls and surveys and surveyed many international students in our campus and got our data. And also, we discussed it together with our team members and created a solution for them, including and making one technology as a solution. So let's get into it.
So this is the data from our Google Form survey that we conducted to our friends around the campus. So more than 50% and almost 70% says campus communication should be made bilingual. And all of them agree that the better English language support will improve the campus experience. And the budget on the right says the areas of the campus that are most affected by the language barrier is campus announcement and events.
So let's talk about our sketches and selected ideas and reasons why we chose the sketch. So our vision for the project was clear from the beginning to design a user-friendly, technology-driven kiosk system that fosters inclusivity and bridges the language gap barriers in the university. So we started the design process by identifying the key challenges that we are facing right now as international students in the campus. So actually, the first one is difficulty understanding campus announcements and events written primarily in Korean, maybe like 90 or 98% of the time. And the second one is struggling in navigating an unfamiliar campus. When I first came to the campus, for example, I was really struggling how to find the right classrooms of my subjects, and also to understand the numbers and the letters of the rooms. So the next one is limited access to important resources like event schedules and document printing. So these are all combined reasons why we are going to come up some solutions with language barriers. So from these insights, we transformed solutions and prioritized idea that could address these issues effectively. So key features like digital maps, event calendars, and multilingual support emerged as essential components to make the sketches of the kiosk system. So additionally, the kiosk provides additional resources like real-time updates or on events and announcements to save time and reduce dependency on external devices. And also multilingual navigation aids, making it easier for international students to move confidently across the campus. So our decision was driven by the belief that technology can enhance inclusivity on the campus. By offering comprehensive support, we aim to foster a campus culture where all the students, regardless of the language or background, feel empowered, valued, and connected in the campus with other Korean students and the staff, and by themselves too. So this kiosk reflects our commitment to creating an integrated university experience for everyone, ensuring no one is left behind. So, thank you so much.
The reason why we use kiosks is mentioned in the previous slide, and it is because of its potential to be able to implement a lot more advanced features than the translation device. So first of all, we included the printer so that students can print out their documents and also the lecture notes and sheets and everything out of the kiosks just by using their student ID and then tap it into the NFC reader, which is right below the screen, and then it will directly leads them into the iClass or Inha portal already logged in. So in the second floor of the kiosk, which the inside second floor, we'll have a main CPU that will handle the most part of the little bit more complicated stuff like a graphical user interface and IoTs and stuff like that. And we have a modem right beside the CPU. It is obviously for the network connection so that we can have a fast and convenient access to our school websites and other different kinds of processing networks. And at the very bottom, we have a fan cooler paired with a power supply unit. So it is separately ran by the Arduino, which I will give an overview right after this slide. Additionally, there's a tray table at the front, and on the back, there's like a security door paired with a lock and a ventilation vent. So yeah, whenever we want to access to the CPU, printers, and power supply units, we can just open it, lock kind of like a door, and then access to the internals of the kiosk. And we also consider like very deeply how we'll have a display, like a little bit, some sort of kiosks a little bit tilted backwards, but we want to have it like a totally straight up. And it is because we'll also use the kiosks as a display of random advertisements and then campus announcements when it is not being used. So it should be a little bit visible from a quite distance, and then most of the kiosks are like normally 6 feet tall, but when we are too close to kiosks, which is like a normal operating distance of the user and the kiosk is feet, in that kind of situation, our field of view is a little bit restricted. So we have to balance it out to be convenient for a user and to be easily visible as a announcement display around the campus. So while the central processing unit, the CPU, is controlling most of the advanced and complicated parts, we implemented the Arduinos for a little bit easier ones using different sensors and codes. So the first one is the proximity sensors. It is obviously for the detection of the objects which is near the kiosk or not. So if the sensor detects an object, we will set the Arduinos and the codes to immediately turn on the kiosks. So this particular features is demonstrated in here using a light bulb. So if the object is getting closer and the sensor detects it, it will turn on the kiosk, which is a light bulb in this case. This is the code for the proximity sensors. So we will have a proximity threshold of 50 centimeters and a check-in interval of 200 milliseconds. And then we'll set up the functions, and we'll have a function of turning on kiosks and also for turning off the kiosks. Then it is the function to measure the distance, and if we detect an object within the range of the set distance. So we will execute the turning on kiosk, otherwise it's a turn off kiosk. So the next one is the temperature controlled cooling fan. So we use the TMP36 temperature sensor here and a DC motor as a demonstration of a fan and a L293T motor driver and the Arduinos. So first of all, the TMP sensor reads the sensor inside the kiosk, and if it is below the minimum temperature that we set, it won't do anything. But if it's a little bit above the minimum temperature that we set, it will run the fan at a very lower speed and then increase gradually according to the temperature, but within its threshold of 40 degrees Celsius in this case, the fan will run at the maximum speed. And the code for this is quite simple. We will first have a function for the fan speed, and then we'll calculate the minimum temperature and the maximum temperature. So, and then another function to read the temperature from the temperature sensor. So, last but not least, we have a main function that it's executing whether we should turn on, off, or set the fan speed according to the temperature. So yeah, that's about it.
Hi everyone, my name is Agajo. Today I am presenting our Arduino-based document translation queue project. This system allows users to upload documents and translate them into one or three languages: Spanish, French, and German. The goal of this project is an interactive kiosk that uses an LCD screen and physical buttons for user input. When a user approaches the kiosk, they promoted to select their preferred language. Using three physical buttons, they can choose from Spanish, French, or German. Once a language is selected, the chosen language is displayed on the LCD screen, and the system is ready for the next step. The user can upload a document by pressing the upload button. The system stimulates the upload process, showing a message on the screen indicating that the document is being uploaded. After that, they can press the translate button to initiate the translation process. Once the user presses translate, the system sends a request to a server to translate the document into the selected language. The LCD screen displays a message to inform the user that the translation is complete. In terms of hardware, the system uses an Arduino with a 6820 LCD for display and several push buttons for interaction. Communication with the server is done through serial messages, allowing for smooth interaction between the user and the system. Now I'm going to explain how the code works. In a setup function, the LCD screen is initialized to display messages to the user. We also configure 5 buttons using pin model as input with a pull resistor. These buttons are used for language selection, uploading a document, and initiating translation. The main logic runs in the loop function. First, the system displays the main menu, showing the available language option. The program constantly checks for button presses using digital read. When a button is pressed, the system updates the selected language and display it on LCD. For example, if the user presses the button for Spanish, the variable selected language is set to Spanish, and this is shown on the LCD. Then a message is sent to the server using serial.println, simulated communication to let the server know the chosen language. The upload button triggers a simulated upload process. When pressed, the LCD display uploaded for a moment, and a message is sent via serial communication to indicate the upload request. Similarly, the translate button starts the translation process. The system displays a message saying translating, sends the selected language and request to the server, and then show translation done on the LCD after the simulation is complete.
Hello everyone, now I'm going to explain the NFC scanning system simulated using Arduino. Let's start with the circuit setup. This circuit represents a simplified NFC scanner that validates access and performs payment and printing feedback. The key components are Arduino Uno, acts as the controller, manages output and processing input. Push button simulates the NFC card scanning action. When pressed, it triggers the scanning and process. Two LEDs. Green LED indicates successful actions like access granted and payment successful. Red LED indicates failures like access denied and payment failures. Then resistors. Resistors protect the LEDs from damage by limiting current flows. Then comes the wiring. The button is connected to digital pin 2 and the green and red LEDs to pins 8 and 9 respectively. The circuit is powered via the Arduino board. Now let's get into the code. The code governs how the system reacts to input and generates feedback. The setup section. The pin mode function initializes the button as an input and LEDs as outputs. The serial begin initializes serial communication to print messages for user feedback. Loop section. The program continuously checks if the button is pressed. When pressed, it simulates an NFC card scan, printing card scan to the serial monitor. Then comes access validation. A random function determines whether access is granted or denied. If access is granted, it prints access granted, and if denied, access denied. The respective LED, green for granted, red for denied, lights up for 2 seconds. Payment simulation. For successful access, the system simulates payment validation. A random outcome determines if payment is completed or failed. If payment is successful, it prints payment completed and lights the green LED. Otherwise, it prints payment failed and lights the red LED. Then comes printing feedback. If payment succeeds, the code simulates printing feedback with a random result, printing completed or printing failed.
So hello again. Today I will talk about how the buzzer system works and it is set up. So in the setup we have actually button, buzzer, LED, LCD display and Arduino Uno. So the buzzer is connected to pin 9 of the Arduino while the button is connected to pin 7 and LED is connected to pin 8. Additionally, we have an LCD display connected with the Arduino for real-time feedback. So the components are interconnected to ensure smooth communication between inputs and the outputs. So let's start with how the system actually functions. So when the button is pressed, the Arduino detects this action through digital input from the pin 7 and it processes the input and actually triggers 2 simultaneous actions. So the first one is activating the buzzer for 500 milliseconds using the tone function. And the second one it does is turning on the LED on the same duration to provide visual feedback. So during this time, LCD displays a message indicating that button has been pressed here, enhancing a smooth user interface. So if the button is not pressed, the system ensures no sound is actually emitted and the LED remains off here, not any lightning. So additionally, the LCD informs the user that the button was not pressed in here too. So let's talk about the code logic here, which is actually really simple. So throughout the process, the button state is monitored continuously using digital read function. When the button is pressed, the Arduino activates the buzzer and LED using tone and digital write respectively. The LCD updates with a message saying that button is pressed. And if the button is not pressed, the no tone function actually ensures the buzzer stays silent and the LED remains turned off, and the LCD updates the message saying that button was not pressed. So a small delay of 200 milliseconds prevents bouncing issues and ensures stable readings. Well, actually, this system has numerous applications such as creating sound alerts, alarms, notifications in various setups. It is really efficient and adaptable to different use cases.